So welcome back again, students. Next experiment what we are looking into is to design half wave rectifier and to calculate ripple factor. So this is the basically circuit diagram. Now let's understand what is rectifier. So once again, rectifier is nothing but diode only, which will convert AC to DC. So rectifiers are the devices which converts AC to DC. Now to perform this experiment, we need diode, a step down transformer, resistor, breadboard, and we need CRO connecting wires. Now since we have understood what is PN junction, then how PN junction and how diode can be used in terms of BJT to perform switching operation using LED on and off. Now same way, this is one of the applications of diode, that is rectifying the signal AC to DC signal. Now this is the circuit. So this is the step down transformer, this is primary coil and this is secondary coil. Basically, the primary coil will be connected to the main power supply, through which whatever that sinusoidal input is there will be applied with the help of mains power supply into primary windings or primary part of step down transformer. So now this part is secondary step down transformer, where this end is connected to positive of the diode, negative of diode is connected to load resistor 1 kilo ohm, another end of resistor is given to one of the points on this secondary transformer. Okay, now the output is measured or output is observed with the help of CRO, which is connected across RL. So this is how the circuit should be remembered. The primary part of step down transformer is connected to AC mains, through which the positive input cycle is applied into primary transformer, and the secondary transformer, one of the point, that is extreme top point, is connected to the positive of the diode, negative is connected to RL, another end of RL is connected to one of the point of this secondary transformer. Now let's understand the working. As you know, during the positive input cycle, what do we call positive input? That is nothing but this. So during this positive input cycle, what happens? Since positive input is applied, this point or this terminal becomes positive. If this terminal becomes positive, positive is connected to positive of the diode, negative is connected to negative of the diode. So what biasing it will become? Forward bias. That is, during this positive input cycle, it is going to operate in which condition? Forward bias condition. As we all know, during forward bias condition, current will flow. So the output can be measured across load resistor. Therefore, we will get the output current flows. Next, during negative input cycle, what happens? This terminal becomes now negative. If this terminal becomes negative, positive of the diode is connected to negative and negative of diode will be connected to positive, and this will be working in which bias? Reverse bias. And during reverse bias, there is no current, therefore there is no output voltage measured will be 0. So during the negative input cycle, output is 0. So similarly, the cycle continues like this. So it clearly shows output contains only positive half cycle. So during negative cycle, there is no output. This function is nothing but converting AC to DC. Now this kind of waveform should be observed in the CRO, and based on the amplitude, VM should be measured whatever Vm is obtained by observing the CRO should be divided by pi to get VDC, and Vrms is nothing but Vm divided by 2. Once VDC, Vrms is calculated, taking the square root and finding the ratio between, that is Vrms divided by VDC to the power of 2 minus 1, to which the square root is taken, will be the ripple factor. Now finally in this experiment we are supposed to calculate ripple factor. What is this ripple factor? Ripple factor is nothing but it is a measure of AC component which is present in output after the rectification. See, basically the job of rectifier is to convert AC to DC, but not complete DC output will be obtained because there is certain AC component which will be actually present in output. That measure of AC component is given by the term ripple factor. So usually why the ripple factor is present during half-wave rectifier operation, the reason is half-wave rectifier can operate only for positive half cycles, where for the negative half cycle it is not going to conduct, because of which ripple factor is more. Ripple factor is more, that is the presence of AC component in the output will be there because of ripple factor. Now how to come? Now these are all like viva question. Then what is the efficiency of half-wave rectifier? The efficiency of half-wave rectifier is not that maximum you need to tell. Why? Because of the presence of ripple factor. Then how to increase the efficiency? By reducing the ripple factor. How to reduce the ripple factor? That is by using the filter. That is nothing but just connecting the capacitor across the load resistor will be half-wave rectifier with filter. So when filter is used, ripple factor will reduce and efficiency will increase. So this is how you need to learn the experiment to remember and to perform design of half-wave rectifier and to calculate ripple factor.